Well, hello everyone. Welcome back. See, God gave me another moment, another day, so I am here. Let me just finish getting myself set up. Hopefully you guys are having an amazing day so far. It is nice and sunny, but freezing than a witch's bleep here in Baltimore. So I want to, because remember, we only got an hour, so I'm just going to kind of hang for just a moment, see if people are thinking about coming in. So what we're going to look at today is we're going to refresh our memory a little bit with function notations, as well as go into that famous word called slope. I tried to put rate of change in the title, but for some reason, it was a little too much. So we had to back it on down. So come on in and be ready to join up because we're going to do a little bit of learning today. Hello, Buckeyes. How are you? Okay, welcome in, welcome in. I'm so excited that you guys are here. Hopefully, hey, Lucas, he's back. Back on the attack. What's going on, man? All right. So we're going to refresh our memory a little bit with function notation. So as we mentioned, a lot of people were kind of getting stuck on this whole notion of what do I do with the F, what do I do with the G, or what do I do with the H? All right. Basically, the F, the G, and the H is going to tell you which function that you're going to use, okay? The X is going to tell you, gotta squeeze in as soon as I can. Let me see if I can scroll down just a hair. All right, so it's kind of giving you that notion. Where's my Zoom? Okay, my Zoom just does not want to work, but that's okay. We'll just deal with it. So we're just looking at which function we're going to deal with. And then the values that's inside the parentheses, those are your domains. Hey, how are you, Lucas? Hopefully everything's going well with you. All right, so right now we have the G. There's my Zoom. There we go. We want to behave. Okay, so we have the G of -5/4. We have the H of 0, and then we have the F of -3. So if we can, we're going to try to do that. All right, I think that fits everything in there. So we have our three functions. We have our F function, which is 3t minus t squared. We have our G function, which is -4/5 x. And we have our H function, which is 2x squared minus 3x plus 1. So with these, the letters in front is telling you which of those three functions you're going to deal with. So if I take a look at the first one, we have G of -5/4. That means I'm substituting this -5/4 for the x value in the G function and the G function only, okay? So when I come here, I'm going to just have my G of -5/4, and I'm going to rewrite my G function, which was -4/5, and I'm replacing my X with the -5/4. Now, as we recall from last time, what's over here with the G of -5/4, this is just to remind you what you substituted for the X. So we don't need that, okay? So all the action is happening over here on the right-hand side. So first off, we have a negative times a negative. So a negative times a negative, that will give us a positive. So we can do either multiply straight across, then simplify, or we can cross simplify, then multiply. So you're going to get the same answer either way. All right. Hey, princess. All right. So if we take it step by step, we got negative times negative. That gives me a positive. And then 4 times 5, that gives me 20. And 5 times 4, that's in the denominator, that also gives me 20. So now 20 divided by 20, that will give me my 1. Okay, where is the x? So what happens is what was inside the parenthesis took the place of that x. Okay, so what we did was whatever is inside the parenthesis of the g function took the place of this x. Okay. Hello, thanks, Get Fit. Appreciate it. So what you just found was the g of -5/4 equals 1. So your input was -5/4 and your output is 1. Yes. Okay, thanks on both sides. Yes, but you only really need to do it on the right side, to be honest with you, princess. All you really need to do is the substitution on the right-hand side, and you're doing all the work on the right-hand side. You're only bringing down your g function at the end, because what you're finding is basically an ordered pair. So -5/4, comma 1. You found an ordered pair for that g function. Next, can you do differential equation, linear algebra? I'm not doing linear algebra. Sorry, Jordan. That's not my jam. That's more of like calculus, and I do not do calculus. Sorry. All right. Now, for h of 0, let's see if I can switch things. So I think it would have been appropriate if I kept with the same color theme, but here we are. All right. So now we have h of 0. So we're not plugging this 0 into all 3 of the functions. We're only going to plug the 0 for the unknown in the h function. So the h function is this one up here, which is 2x squared minus 3x plus 1. So I'm looking for the h of 0. And I'm going to plug in zeros for wherever I see an x. So I have 2 times 0 squared minus 3 times 0 plus 1. Okay, so we're looking at what is in green. So it says h of 0. So I'm looking at the h function. And when the h function, I'm plugging in zeros for all of my x's. Okay, I'm not doing anything with this h of 0. I know it looks like ho, but we're not doing anything with the ho. Okay, so all we did was substitute the 0 in for the x's. And now we're going to do all the work that's happening here on the right-hand side. Okay. So Steven says it's 1. Or Stefan. Crystal, yes. Is it 1, princess? Okay. Get rid of the question mark. Okay. Get rid of the question mark. Coming answers with confidence. All right. So if we take a look, anything times 0 is going to be 0. So we have 0 minus 3 times 0, that gives me 0, plus the 1. So 0 minus 0, that also gives me 0, plus the 1, and 0 plus 1 is 1. So good job. Holly! Yes, Wally. Yes, princess. It is 1. Good job, princess. There we go. All right. So, Crystal, how are you? So the answer is 1. So that means your h of 0 is equal to 1. So what you just found is an ordered pair for this h function. And the ordered pair is when your input is 0, your output, there we go. Your output is 1. All right. Okay, this makes my math educator heart so happy. Yes, I know, I'm trying. All right, so now here we are with this last function. So we have the f function. So f of -3. So that means we're not substituting -3 to all three of them. We're substituting in that -3 in just the f function. So if we recall the f function, we have the f of -3. I'm going to write it and then slide it over for a second. So wherever I see, this time we have a t instead of an x. Same thing. Whatever's inside this parenthesis, that's your input. They could put a t there, they could put an m there, a p there, a q there, whatever they want to put as the unknown variable. That's fine. But sometimes you will see a t, especially if they're talking about time. Sometimes they use that for a variable, okay? But no matter what it is, right now, we want to find the f of -3. So when we have our 3, wherever we see a t, we're going to put a -3. And I'm going to slide this over in a moment. Okay, just so make sure we all can see. And let me zoom in just a hair so you guys cannot be like, I can't see. All right. So I'm seeing some zeros. I'm seeing some happy faces. Wally loves this. I'm so happy. Okay. Oh, Holly, thank you. All right. Bean Eater, I love your names. Like when you make up your profile names, like how deep did you have to go? Because I see some names, I'm like, say, whoo, what is that? And then some people like myself, I use my regular name. All right, so we have Giorgio. Hello, Giorgio. Giorgio saying 18 beagles. Okay, saying 0. All right, so let's take a look, okay? Remember, anytime you're doing any kind of operation, you want to have your please excuse, my dear Aunt Sally. I actually had one professor, I have a client now, they were talking about, what did he say? Pasta, eggs, meatballs. I'm like, say what? Are you hungry, baby? Are you hungry? Because that is not helping. A lot of people are just so engraved with that. I know, we're trying to be fancy, but there's times you don't need to be so dang fancy. All right, so parentheses. We don't have anything inside the parentheses to combine. Next is exponents. So what is being raised to the second power? This I need to clarify. Okay. All right. It's 9. No, it's 0. Okay. And Preacher J is here saying -18. Okay. Thank you, Soleil. So the -3 is being squared. So this means, and I'm going to write it up above, right up here, -3 times -3. That's what this means. And this is vital because we're dealing with the signage, right? We're dealing with signage. So negative times negative gives me a positive. So it's not going to be a -9 that's happening from the square. It's actually going to be a +9. And the reason why I'm putting a parenthesis around it is because of this negative sign that's right, or this minus sign that's right outside. But let's combine the next part. We either have multiplication or division. Right now, we have multiplication. What do I get from here? 3 times -3. Okay. I hope that's like from your previous answer, Giorgio. Okay. All right, so I'm seeing some -9s and I'm seeing some +9s. Okay. Sue, how are you, my love? All right, so it's going to be negative because a positive times a negative gives me a negative. All right, so a positive times a negative, when the signs are different, when you're multiplying or dividing, your answer is always going to be negative. But when the signs are the same, like right here, when the signs are the same, when you're multiplying or dividing, your answer is going to be positive. All right? So now, let's take a look. I matched the wrong answer. Okay. So now, let's take a look. We got -9 minus 9. Okay? So it's -9 minus 9. I think a lot of people, when you squared, you probably got a -9 because we probably forgot about the signage. But now, -9 minus 9, since both of them are negative, and you're basically adding, your answer is going to be a -18. And if you don't believe me, so you owe $9. Now, just like my bills, I owe another $9. Put a couple zeros on the end of that. It'll be so truth of a fact. All right. So I owe $9. Now I owe 9 more. So guess what? I owe 18. So your F of -3 equals -18. So you basically found an order pair for that F function, and the order pair is at -3, -18. Okay, so let me take a look. Going to study calculus soon. All right. Yes, so you're definitely going to need this. How are we doing it? I like how you said that. Oh, thank you, Chaz. I appreciate that. I tried to break things down, okay? I'm the type of person, I don't like to judge. When I was growing up, I used to suck at math. Horrible. Absolute fractions, no. Word problems, hell no, not doing that. All of a sudden, I was an instructional assistant at a school, and I had the teacher just mention to me, or just mention to the class, guys, don't worry about fractions. Fractions is nothing but division. Completely blown. My whole world has changed. Right? So, I mean, it's just, those are like the little things that really like kind of resonates. And then I saw how some teachers were teaching and how some teachers were not teaching. And that motivated me to become a teacher, in addition to my 3rd grade teacher who really motivated me to be a teacher. So I want to say, fast forward, I left the classroom 22 years later, and now I'm online tutor. This is my 5th year. And then all of a sudden I felt like sharing my talents with the world. Why not, right? So this was a little thing was what we did last time. So remember, it all depends on which function you need to pick so you can pick the right function so you can get the correct answer. So that's one. Now, the other thing we talked about a little bit is looking at what's called domain and range. All right. So I have a table here. And in the tables, we have some order pairs. We have 0, 7, 1, 6, 2, 6, 3, 7, 4, 8. All right. So this is a relation, a set of order pairs. That's a relation. But in order for it to be a function, or actually, should I ask you, is this a function? You can use Y for yes, N for no. You can use thumbs up for yes and thumbs down for no. Or you can just be like, yes or no. Whatever you feel like, you get to choose, right? Hey, how long have you been on? Since 1 o'clock. So, like 19 minutes. Okay. All right, so Leanne is saying no. Lucas, not too long. Come on. All right. I'm an A as well. Yes. I mean, that life, I'm telling you, trying to, especially if you are paired up with a teacher that's just like, I basically invented math and this is the way I'm doing it. And then all of a sudden you're like, okay, I have to help this kid not to basically jump off the edge because of that. Or another one would be you have like a great teacher, is a great kismet, and just sometimes the kid just don't get it. And then you really have to dig deep with like what they like to figure out so they can stick with it. All right. Nope, didn't miss much. We're just kind of like reviewing a little bit of what we did yesterday. All right, so Sue and we got Jennifer. We're saying Y's, yeses, and I got a couple with no's. So here's how we check. Yesterday I used this terminology. So say this side, my input are the names of people. So I'm going to say names, and my results, my output, are birthdays. Okay. So, is it possible for multiple people to have the same birthday? Yes or no? Y or N? Is it possible for multiple people to have the same birthday? Okay, so yes, 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 Holly, yes, Lucas. Don't be afraid. Hey, TJ, or TJ. Tor, welcome in. Okay, Gail. So it's possible for multiple people to have the same birthday. And that's what's happening here. Like this person number 1 and this person number 2, they're sharing the same birthdays because they have the same results. But is it possible for one person to have multiple birthdays? If so, Mother's Day should be like sainthood for that woman. Like complete sainthood. Like don't, whatever she wants, give it to her. Like seriously. All right? But all right? So, is it possible for one person to have multiple birthdays? Yes or no? I know, I'm just being silly. But if you really think about it, right? Be like, all hail you, because I wouldn't do it. All right, so no, thank you, Leanne. No, it's not possible. So here's the thing. Your X values or your inputs cannot repeat. One person cannot have multiple birthdays. Like here's another one, 0 and 7 and 3 and 7. They basically have the same birthday, which is cool. But 0 doesn't have a birthday here and a birthday here and a birthday down there. No. So as long as my X's are not repeating, so I'm going to put them over here. So I got my 0, 1, 2, 3, and 4. As long as my X's are not repeating, that's perfectly fine. This is a function. Oops, you can't even see that. My horrible handwriting, okay? Now, this part is the mapping. So we have 0, 1, 2, 3, 4. We're doing our list of our X's. Now we just need to list our Y's. And if you recall, we put it in numerical order. And if they repeat, if my Y's repeat, that's perfectly fine. We just have to write it one time. Okay, so just one time. Thank you, Lady Lavender. So now how we do the mapping, we're just going to draw arrows to its destination. So 0 goes to 7. 1 goes to 6. 2 goes to 6. 3 goes to 7. And 4 goes to 8. All right. So this is how you would do a mapping. Okay, it's almost like you're just listing out your numbers that are given to you as ordered pairs. All right. How are we doing? So range is basically referring to all the possible output values. Exactly, Lucas. Exactly. Okay. So if I may take it down to the next part, we're going to list out our domain. Some people like to put the X to emphasize that the domain is the list of your X's. So sometimes it will say X such that, and they'll just list all your X values. So in our case, we're going to list all our X values in numerical order. So we have our 0, 1, 2, 3, and 4. Then I do my heart, and pointy nose, and a baby's butt. That's how I do my brackets. So your domain is the list of your X values, of your input. Your range is the list of your Y values. And just like I said earlier, if they repeat, you don't have to write it more than once. So my Y values is going to be the Y's such that 6, 7, and 8. Heart, nose, baby butt. Okay? Okay, got it. Cool. All right. So that's part of what we did yesterday. All right, with the function notation. I wanted to take an extra day with this. All right. So what we're going to work on today, does anyone else need this? Because I'm about to take it away. We're good? We're good? Okay, got it. All right, and hey, Sunny Rose. Okay, boom. All right, so now we're going to talk about slope, as a lot of us are basically calling it rate of change, all right? So you probably heard of the word slope. For some weird reason, people struggle with slope. It really is, it's almost like it's a mind bender. And I'm like, okay, so let me see how I can break it down so it won't be so tragic. Now, slope is also seen as, let me see, here we go, we can do that. So for my formula section, I see slope as the delta y over delta x. So delta is a Greek symbol meaning change. So if you have all your like sorority sisters, they all go to delta, like, ooh, ooh, you know, all that. I don't do that. I don't want to insult anybody, but you know what you guys do. So delta means change. So we're basically looking at the change of y's, and change can mean difference of my y's over the change and the difference of my x's. Now, this is the part that gets a lot of students. When we're looking at change, a lot of us know it as the y sub 2, and I think everyone says y2 minus y1. It really means y sub 2, basically the y value of your second coordinate, the y value of your first coordinate, over the x value over your second coordinate, minus the x value of your first coordinate. Now, people are okay with the y's, but they always screw up the x's. So since, especially us, we read from left to right, you can also say, let me take the y value of the first minus the y value of the second over the x value of the first minus the x value of the second. You're going to get the same answer either way, okay? But here's the thing. You have to, whatever pattern you go, they need to match up. So if you're going to start with the second, that means for the x's, you got to start with the second. If you're going to start with the first coordinate, that means for the x's, you have to start with the first coordinate, okay? All right, I can't get it right. And that's fine. Okay, the triangle is delta. Yes, it is. So delta means change. All right. So with slope, a lot of people also know it as rise over run. So if we think about our y-axis goes up or down. Okay. Our x-axis goes left to right. So you want to rise before you run. You want to rise up out of bed before you run to the bathroom in the morning, okay? Or maybe that's just me as I'm getting older. Shameless plug. But when you want to rise up, I like to put it in sports things. Like you want to rise up to get the rebound before you can run the floor. So, and it's like you want to rise up to the third level in order to run to the food court. That's, you know, Give me something and I'll try to put a rise or a run to it, okay? So these are the things that we need to keep in mind when we're doing slope. Now we can do slope basically 4 ways. We can do it algebraically, which deals with this formula. We can do it graphically, which deals with basically looking at the rise or a run. It's almost like direction. Then the other one is looking at a table. So if I was looking at a table, I'm going to do like this. So if I got 1, 2, and 3, and if I got 5, 4, and 3, so I would look at the difference or the patterns. So the pattern is going down 1, and the pattern for my x's is going up 1. Okay, so I'm looking at the pattern of my y's over the pattern of my x's. So in this case, my slope, which is also usually represented by the letter m, is going to be -1 over 1, which simply, if I really simplify it, will give me a -1. Okay? How are we feeling before I even mention the next one? Because all of a sudden it just seems like everyone just stopped. What is she hammering on about? I was fine with the rise of a run, and then all of a sudden everything went crazy. Okay? All right, everyone's good? Nope. Is Leanne, does it mean like you're not good, or I'm good? I'm just following along right now. Talk to me. Hello, Martha. Okay. Explain. All right. Not good. Oh, okay. All right. Let me show through examples. Okay. Let's be fair. Let me show you guys through examples. All right. So I got lost. I know. I went like 3 different directions. I do apologize. All right. So let's say we do it algebraically. So for the first example, I have, let's say, -2, 0, and 3, 1. So I have 2 ordered pairs, okay? So long, something I used to ace. Right, not a problem. So I have 2 ordered pairs. Since I read basically from left to right, okay, I'm sorry I got to be an American right now, but this is what I know, okay? So please, be gentle. So since we read from left to right, this is my first point. And points have a coordinate. So the coordinates is usually x and a y. But since this is the first point that I see, that's going to be my x sub 1 and my y sub 1. When I go to the second point, these are also x and y's. But the x here, this is my second point, so that'll be my x2 and my y sub 2. Okay, are we okay so far with the labeling? I'm good with a thumbs up or a Y. Hello, Zoe. Okay, I'm good with a thumbs up or a Y. We read left to right in the UK as well. Okay, but see, I also might have some people from like other areas. I've noticed that a couple times. Okay, will the numbers always be in ascending or descending order? Why? Not necessarily. It's always changes. Melody, it always changes. Okay. All right, so now, if I'm going to solve this algebraically, so I'm going to show you both of these. Ooh, I'm saying these and you can't even see it. I'm going to show you both of these so you can see that you're going to basically get the same answer. So if I go with the traditional, the difference of the y's, so we have our y sub 2 minus our y sub 1 over my x sub 2 minus my x sub 1. So now we're playing the matching game because we already labeled what it will be my x1, y1, and all that stuff up here. So if you notice, my y2 is 1. There's a minus sign, so I bring that down with the formula. My y1 is 0. So let me stop right there. See how you guys are doing. Okay, so my y2 is 1. My y1 is 0. Okay, all right, good. So now we're doing the x's. So my x2 we labeled as 3 minus my x1, which we labeled as -2. Every time I plug a negative in, I like to put a parenthesis around, and I'm going to explain why in a moment. But do you see what's happening? I'm still keeping up. OMG, yes. Good job, Nina. All right, good. Jennifer, I don't want to leave. Okay, good. Leanne, I just want to make sure. All right. So now, the reason why I put parentheses around every time I'm substituting a negative, because our formula originally has everything doing subtraction. Remember, delta means change. Okay, change means subtraction. Okay. So as we're changing our lives, we got to get rid of something, right? Every time we're changing, something needs to leave. Either our friends, our families, whatever we got to do in order for us to progress. I know it just got real dark in a second, but here we are. So every time I substitute a negative, I like to put a parenthesis around it because if you notice, down here in the denominator, I have 3 minus a -2, not 3 minus 2. Everybody gets that screwed up. Everybody. Every single solitary person. I've also seen people with their programs. Once in a while, they mess that up. So it happens, okay? So when you minus a negative, I'm just going to write it all out this time. When you minus a negative, that means it turns to a positive. Everything in this numerator stays exactly the same. So I just want you to see the transition from here to here. Okay. That's where I went. Hey, Kara. All right. All right. So yes, my denominator will be a 5. Good. So what's going on with the numerator? If the denominator is 5, what's the numerator? I think Leanne, someone mentioned it. Who was it? Oh yeah, Leanne mentioned it too. Yes. Yes, Lisa. Yeah, I see it now, Leanne. Sorry. Yes, Sue. Yes. So 1 minus 0 will give us 1. All right. So this 1/5 right here, this is my slope. Okay. So the 1 is my rise. Okay, so that means I'm going up 1 unit because it's positive. The 5, that's my run. And since it's a positive 5, that means I'm going to the right 5 units. So it's almost like you're giving directions. Hey, Pops, how you feeling today? Okay, so this is what's happening when you're dealing with slope. You're finding direction. Okay, your slope is really, as some people will call it, gradients. Have you ever traveled, I want to say cross country, maybe you got to like a mountain pass and then you see a sign. Okay, you can laugh at my drawing because it's going to be hilarious. You're going to see a sign which has like a mountain pass. It has like a percentage and then it has like a truck. Yeah, go ahead. Laugh hilariously because I am right now. Didn't go to college for my J. Okay. So If you have gradients, it's telling you basically how steep is the next part of the mountain pass, or how steep is the hill. Like if you have a lot of truck drivers and they're driving up these steep mountain hills, they might have to pull over at one of their little truck stops or the pauses, put chains on their wheels because of the gradient, the steepness. That's what you're finding with slope. Slope, I'm learning this in school right now. Awesome. So what's happening with your slope? The larger the slope and positive, the steeper the hill is going to be. I used to work at a school that had like a hill that was huge. And it cracks me up because the kids were like basically in shape by the end of the school year, because every time they had to climb up that hill every single solitary day, you would see them first period huffing and puffing like they're about to die. But then by the time like May, they were in shape. I don't know about Olympic size, but they were definitely in shape, right? Because they kept going up this steep hill just to get to school. All right. The run is the x-axis, yes, and the rise will be the y-axis. Correct, Lisa. This was one topic that always escapes me. Yes, okay. So you're finding the steepness. So that's how we would do it algebraically. Now, if I wanted to, there's 4 different types of slopes if you look at it as a graph. I'm going to do another example algebraically, but I want you to see the graphs. I don't want you to miss out on anything. So if I'm going to come down here. Just going to make like 4 small graphs. So we got that one. Yeah, I do my graphs with pencils. I know, I'm old school when it comes to that. I'm going to see if I can put like 2 there. And then I'm going to put like 2 here. And I'm going to squeeze one right over here. That's why I love doing my dot drill thing, because it makes the graph so much cleaner. All right, so we have 4 different types of slopes. So let me shrink that bad boy down. All right, so if I want to, I can probably see if I can use this 1/5, okay? We always have a starting point. So I'm going to start here at the origin. So let's say that's going to be my starting point. And if I wanted to go, let's say my slope, let me shorten it to like 1/3. Let's say my slope was 1/3. That means from my starting point, I'm going to go up 1, okay, because that's my rise. And then from there, I'm going to go, since it's a positive 3, I'm going to go to the right 3. 1, 2, 3, and plot my point. So I like to say, okay, this is my house, and I want to make it to my friend's house. So what directions I'm going to give? I'm going to say, all right, go up 1 block, and then turn right and go down 3 blocks, and you get to his house. 1, 2, 3, boom. All right. So from left to right, this graph is increasing, okay? The way you read your graphs is almost like the way that we read here in the States, from left to right, and also in the UK, from left to right, okay? If it's going upwards, that means as my X's are increasing, my Y's are also increasing. So this is called a positive slope, okay? So as the X's are increasing, the Y's are also increasing. Okay, hopefully that kind of helps a little bit. So now, let me take a pause to see what is going on here. I'm sorry, I just kind of like ignored stuff. Why? That's so bad. Is it applied to airplane when it claims? Is it applied on airplane when it... Oh, yeah. When the airplane, when you're taking off? Yes. Yes, you can definitely deal with the takeoffs. What notebook is this? That's nice. Hey, Jules. It's a notebook that I designed. I actually have it on Amazon, and I did update my website so you can see it a lot clearer. And you can order directly from there. So I have notebook envy. Yes, I got tired of my students just like their stuff was all over the place. So I leave a section for the formulas and then a section for steps. Okay, slopes are used for linear equations. Yes, Leanne, good. Yes, and the reason why, it's giving me a straight line. Anything that's giving me a straight line is linear. So if you think of the word linear, it actually has the word line in it. Yep, so it has the word line in linear. So that's the positive. So if I had a slope, let's say if I'm starting here at 0, 0 again, and I wanted to go down -2, so -2/1. So that means from my point, I'm going to go down 2, 1, 2, and then I'm going to go over 1 and plot my point. Okay, so remember your rise, and I know it sounds weird because you're like rise, usually rise up, but rise pertains to the y values. You can go up or down, okay? If it's negative, you can go down, and then you can go to the right 1 unit. But here's another thing. This is only with negatives. It gets crazy. Well, you can do it with positives too, but mainly with negatives. If you see -2/1, this also means the same for +2 over -1. Notice either, not both, but either the numerator or the denominator is negative, not both. So if I had this, if I start here at my 0 at my origin, I could go up 2. And let me change colors so you can see that a lot better. So if I start here at the origin and I go up 1, that doesn't help. Still looks like the pencil. Here we go. All right, so if I go up 1, 2, but then for the -1, I will go to the left 1 to make my point. Okay? So when you have a negative slope like this, you get to pick and choose where do you want the negative. Do you want it in the numerator or do you want it in the denominator? And you notice that those 2 points are on the same exact line. How are you guys feeling? Because usually negative slopes is what gets a lot of people. Okay, slopes are used. Hold on. Oh, thanks for the follow, Jules. Hey, how are you? Fantastic. I'm heading to Amazon now. Oh, thank you. Okay, well, I'm here. I'm running my miles on the treadmill, but watching Miss Audrey. Oh, that's awesome. Love that. I'm a little jealous. I need to get my butt back on the treadmill. But how do you know the 1 is on the right or the left? Okay, so I think I probably answered it, but I'll say it again. So if it's positive, it goes to the right because all my positive, it goes to positive infinity. All my numbers are positive to the right. Here's negative infinity. All my signs are negative to the left. Okay? So when I had the -2/1, that means I start at a point, I go down 2, and then to the right 1. If I choose to make my denominator negative, that means I'm going to go up 2, but to the left 1. Always the ones like y. Yes. I didn't realize that. Magic. Another one. Of course. Please. Of course. Thank you with the please. I appreciate it. Because I know sometimes we get excited. We're like, oh, we're getting a little demanding, right? You're getting a little antsy. All right. But there are two more. There are two more slopes. All right. So one of them is when you have y equals, I'm going to say y equals 2. Or, yeah, I can say y equals 1. We can do that. We have y equals 1, and the other one is x equals 1. Why not? We'll just keep it in the family. All right. Now, y equals 1, okay? So anytime you see a y equals, that means the line that you're going to draw is only going to go through the y-axis. And remember, the y-axis goes up or down. So when you see y equals 1, here is when y is 1, right here. Okay, that's your positive 1. And basically, you are drawing a horizontal line right through that point. This is what's called a zero slope. Okay? Zero slope or horizontal slope. So that means as your x's are increasing, your y is exactly the same. Okay, as your x's are increasing, your y's just stay exactly the same. And I just realized I didn't do that for the negatives because we got so excited. So for the negatives, as your x's are increasing, your y's are decreasing. Let's see if you can see that. Okay. Okay, so this is called a negative slope up here. All right. So I like to make sure that it's coming back to me. Thank you. Not a problem. Good. All right. So positive goes to the right, negative goes to the left. These were always the ones like y. Yep, I just lost it. Nope, you didn't lost it. It's still there. It's still there. So when your slopes from left to right is going down, it's going to be negative. So that means as my x's are increasing, my y's are going down. They're decreasing. So that's why that's a negative slope. Over here, as my x's are increasing, my y's are exactly the same. So these are a zero slope. Okay, anytime it says y equals 1, y equals 58, y equals, you're only crossing the y-axis. It's not going to be on a slant. It's going to be a horizontal line. So is that a function? Yes, it is, Lisa. And how do I know? Because if I use my pencil and I kind of go along that line, I'm only hitting. My x's are not repeating. These are all names and they all have the same birthday. Okay? Say I'm in one village and everybody was born on the same day. That would be creepy, but here we are. My sister called and I told her you were alive and I would call her back. I can't miss your teaching. Oh my gosh, Leanne, that is so sweet. Thank you. Hopefully it wasn't anything important. Right? That would be creepy. All right. So now the last slope is when we have x equals 1. All right. So here's my x-axis right here. And this is when x is equal to 1. And it's not crossing the y-axis at all. It's just going to be straight up and down. Okay, like that one flick where all the kids were born on the same day. Yes. No, just a chit chat. So, is that a function too? Is this what's called slope? Yes. Yes, I think that's what they do call glide slope. I'm not really strong familiar with aviation, but I will actually look that up and see what it is. Now, is this a function? Is this one a function? Hello, Milton. Thank you for the follow. I'm like tapping it vigorously. Shaking my phone, so sorry. Okay, is this a function? Yes or no? Go ahead, put something up there. Why? No, thumbs up, thumbs down, not sure. Let's see. Okay, I appreciate the question marks as well. Yes, because it crosses only one point. I don't know. Good. No. Yes. I'm afraid I don't know what a function is. Okay, not a problem. All right. Anyone else? One more. I was like, do you have a YouTube? I do have YouTube. It's ACG Math Tutoring. Or you can just type in my name. I try not to be. Okay. Looks very familiar too. Okay. And then I have Milton with a no. All right. So it's saying X. So remember I said that this point is at 1. So let's say the order pair of this is 1, 0. I have this point right here. Let's say that this is 1, 2, 3 for the y-axis. So that means this point is 1, 1. This point is 1, 2. This point right here, this is 1, 3. This point right here would probably be 1, 4. And I can be very appreciative of, say, this point right here. This is at 1, negative 2. What do you notice? Okay, perfect. Maybe the domain is used once. No, it's not. Yes. What are you guys seeing? What are you guys seeing now? If you can see, let me zoom in a little bit so we won't have to squint. What do you know? All of a sudden people are like, yes, thank you. Appreciate that. Okay, what do you notice? And I think it was Milton that noticed it first, if I'm not. I like to give credit when credit's due. Oh, and is it Javi? He also mentioned it, or she also mentioned it as well. Okay. Okay. All on the x-axis, it crosses more points. Input is, thank you, Kara, there we go. Input is the same, but the output is different. Damn, I have an exam next week, I'm probably cooked. No, you're not. You're doing good, okay? Can I look at your homework? Okay, there's not a 1, negative 1. Oh, okay. All right. So we got 1, negative 1. Okay, that's true. But I wanted to show you that all of your inputs are exactly the same. Okay, so we're saying that one person has all these different birthdays. God love his mother, okay? All these different birthdays. One person cannot have multiple birthdays. I'm not talking about leap year and all that foolishness. I'm talking about one person was actually born on multiple days. No, okay? Just no, all right? All right? So when you see a vertical line, one, it's not going to pass the vertical line test because we're just looking at just a snapshot. Remember, with these arrowheads, that these lines are going all the way out to infinity. Positive infinity on the way up, negative infinity on the way down. So we're just seeing a little snapshot of it. So this is not a function. I'm just going to write this down. Not a function. And then here's the thing. My x's are staying the same as my y's are basically increasing or decreasing. So as my y's are increasing or decreasing, my x's are exactly the same. Okay, not a function. So this is called got a little crazy with my N. Undefined slope. Okay, so this is an undefined slope. So you either have four slopes. You have a positive slope, a negative slope, a zero slope, zoink, zoom that in there, or an undefined slope. Okay, and your undefined slope is the one that's not a function. Positive, negative, and zero slopes are functions, but your undefined is not. Okay, so not a function. Yep, not a function. I almost understand. All right, good. No function. Good. Well, hello. And then Coco, thanks for the follow. Could you zoom out so I can screenshot the entire page? I will try my darndest to fit the whole entire page in here. We might have to take it in multiple shots. Okay, so let's take this side so you can get the formula and the steps. So let me know when you got that. All right, I saw a little heart. And then let's see if you can get, are you able to get all of this, or is the comments in the way? Okay, you got that. Do I need to cut this in 2 sections, Lynn? See, I'm all about this. I'm all about sharing because one, I didn't invent math, so I cannot copyright this. The only thing I copyright is like my little design of how I did the notes. Other than that, okay, got it. All right. So I'm one of the people that I love to share. Again, if you like the structure of my notebook, I have it on sale on Amazon, and it's not just a notebook. It also has references. Here's factor sheets from 1 to 200, especially when you get into the breaking down of radicals and what else are we doing? Factoring and all that, and just simple multiplication, because you guys, a lot of students cannot read multiplication tables. Also, here goes the rules of integers with addition, subtraction, and the multiplication and division at the bottom. Then word problems, if you need any of that. You have adding, subtracting, multiplying, dividing when it comes to the most popular word problems that are used. And we got, I don't want to keep pushing, but order of operations, properties of exponents, and then hey, look right here. What do we got here? We got slope, rate of change, shown in both ways, just in case you forget about it. Okay, we are going to go into equations of the lines a little bit either later this week or the beginning of next week. I don't want to jam up too much stuff in your brains. Do you have a Discord for homework help? I actually am going to start up almost like a homework help or a study group. Just take a look on my website to see what you need. The book's called The Ultimate Math Notebook. You can type in my name, Audrey Codner, and on Amazon, and all my books will pop up there. Okay, and actually, if you go to my website, I actually have a link that takes you directly to the notebook. And if you're going into trig, Pythagorean theorem, SOHCAHTOA, and then also when you're in Algebra 2, unit circle, that's coming up if you haven't addressed that yet. Does it go over fractions? If you have a younger, I do have one for my 4th through 6th grade. That their forms is a little bit different. but I still have the factor sheet, but I do go over fractions on this one. I actually have some examples of some fractions if you want to do hands-on activities, if you have younger ones. And then also the whole conversion from percent to decimal, fraction to decimal, percent to fractions, all that fun stuff, as well as the fractions operations. So the addition, subtraction, multiplication, division, and as well as decimals. So I have the decimal operations and then the place value. Okay, looking at the place values. And there was something else that was different. The rounding, long division, conversion. We deal with a lot of this, not just in elementary. I'm actually going to put it, like, upgrade my books a little bit and put this in there because a lot of our older kids deal with this, especially when they get into Algebra 2. Area and perimeter is in there, and especially volume and surface area. And like I said, examples of a word problem. So if we got the words over here, there's an example that they can follow through on. And I think that was it. And then other than that, some brain breaks. Brain breaks help the kids to refocus. You know, sometimes you just need to do something mindless for a second to kind of bring you back. All right. Do you recommend for 4-year-olds? Now, for 4-year-olds, I have a friend, Lynette, Learning with Lynette. I'm not sure if she's here. She does math through use of the abacus. If you type in, like if you try to text someone and you type in the word math, there'll be like this little box with beads on there. That's an abacus. And she does amazing stuff that will help you're perfect to help her with the counting and adding, subtracting, multiplying, and dividing. And she actually goes live, and I'm not sure when she does, but she does have a TikTok, and it's called Learning with Lynette. Let me see if I can put it in here. Okay, so Learning with Lynette. Yes, she's awesome with it. I mean, yes. For me, I have to do the older ones. I have patience to a point. I'm not even going to try to lie. I'm one of those people that you bring your kids over, you got literally like an hour. And then you better figure something out because this ain't going to work. The Ultimate Math Notebook, I believe, is what she says is called. Yes. Thank you, Lucas. Okay. All right. So, luckily, my 2 o'clock is not here today, so you get to have me till about like 2:30. Aren't you lucky? But I really want to make sure we get this down. So we have those 4 difference. We have positive, we have negative, we have zero slope, and we have undefined slope. All right. Now, as I said, I want to do another algebraic, and then I'm going to show you numerically, how to find your rate of change. So I'm going to come over to my other side, just as cute. Okay. So I like to have grid paper on the other side to kind of help with the graphing. Where is my stuff? I love how I had like things organized and you just like move like one thing over and it's like, I'm a get in. Like, what is happening here? All right, so here we go. So remember, we're using 2 order pairs. So let's look at, don't want that one. Okay, we're gonna do this one. Let's look at -2, 5, and 1, 4. So we're going to find this algebraically. Anytime they give you 2 order pairs, that means they want you to find it algebraically. So we can use one of 2 of the formulas. So we can do, I never did show you the other way, did I? I am slipping. I'm just so excited that you guys are learning. I'm just Yeah, it's just like me when I was in the classroom, like, I'm so happy. And I just totally forgot that. I was like, oh yeah, I was supposed to show you both ways. All right. So this is your first point. So that's your x1 and your y1. This is our second point. So that's your x sub 2 and your y sub 2. All right. Once you get that, plug her in. Oh, Firestorm. All three of them have the same, but this is the most popular one because this is the one I use a lot. Okay, so you can use the one with the bubbles, all the bubbles in the front. There's like the bubbles one, there's one with green, and there's another one that has like pastel colors. I think hexagons on them. It's been a minute since I stared at it. Do you do 7 years? Do you do 7 years? He's already in the second grade in math. I do not do 7th. I do 7th grade, so most of those kids are like around like 12, 13 years old. I can tolerate a 7th grader or a 7-year-old, but I haven't taught, especially for online, I haven't taught online, to be honest with you. Okay. All right, so I have one person that's telling me, Lynn telling me -1/3. Okay, what did you guys get for answers? Or is everybody worried about buying the book right now? We're trying to get the book, Audrey. Okay, so while you're working on that, I'm just going to take a quick sip of water. I have to remind myself to drink water. Okay, so Jennifer has -1/3. Oscar Mayer, love that. Let's have Oscar Mayer wiener. Oh, Lucas, you're in the #1 spot. Look at you. That's funny. Hello, Desiree. All right, Princess has -1/3. All right, so let's take a look. We have our y sub 2, which is 4, minus my y sub 1, which is 5, over my x sub 2, which is 1, minus my x sub 1, which was a -2. So anytime we have a negative, we want to put a parenthesis around it. Okay? Hey, Kevin. So now, 4 minus 5, that gives us a -1. Now, don't forget, down here, it's not going to be 1 minus 2. It's going to be 1 minus a -2. So when you minus a negative, that means it turns positive. So in actuality, you will have a -1/3. Okay, so we have a negative slope. All right. I missed first step. Okay. So first step, once you get your ordered pairs, label them. Okay. The first thing is, since we read from left to right, this is going to be my first point. The coordinates of a point is x and y. So I label it x sub 1 and y sub 1 to represent the x and y values of the first point. Then you go to the second point. This is your x sub 2 and your y sub 2 because this is the x and y value of your second point. So now we can go to our formula, which is the change of y's over the change of x's. So you can do your y2, which is your 4, minus your y1, which is your 5. So you're plugging in what you got labeled up top here. So your x2 is 1 minus your x1, which is negative 2. Yes, so 4 minus 5, that's where the negative 1 came from. Yes. Okay, awesome. All right, so as promised, like, I don't know, since the beginning of this session, I'm going to show you the other way. And the other way is your y1 minus your y2 over your x1 minus your x2. I find this a lot easier because since I read from left to right, it's easy for my eyes to gravitate to what I need. So my y1 is 5 minus my y2, which is 4. And my x1 sub 1 is negative 2 minus my x sub 2, which is 1. So now I have 5 minus 4, that gives me 1. And negative 2 minus 3, negative 2 minus 1, which is the same as saying negative 2 plus negative 1. This gives me a negative 3. Okay, so I owe $2. Now I owe another $1. That means I owe $3. And if you notice, you're basically still getting a negative slope. But the difference is the negative is not in the numerator. The negative is in the denominator. But it's still a negative slope. All right, back to this. The question will always come with two groups of numbers, right? Yes, if they want you to find the slope, it's always going to be between two numbers. Okay, awesome. Would the perpendicular line of negative 1/3 be negative 3? No. You're right with flipping it, Lynn, but remember it's going to be opposite flip. So it's going to be the opposite of perpendicular of negative 1/3 is going to be a positive 3. Okay, we're actually going to talk about that this week. Yes, so positive. Yep. Don't forget to negate the signs. Everybody remembers the flip, but they always forget about the sign. Yep, not a problem. Not a problem. Okay, so as you can see, as long as your y's and x's are matching up with the 2's and the 1's, and you know that your y's are going to be your numerator and your x is going to be your denominator, you can find any graph, okay, any slope. So that's algebraically. Here's numerically. So if I have a number line, and let's say I have, negative 2, 0, 2, and 4. And my y values is negative 5, negative 2, 1, and 4. And you're probably like, whoa, what are we doing? We're still finding slope. But remember what I said slope was. Slope is the change of your y's over the change of your x's. So we're trying to find the patterns. All right. So if I'm going from -5 to -2, am I increasing or decreasing? Let's start with that. If I'm going from -5 to -2, am I increasing or decreasing? Okay, so Lynn's telling me +3. Who else? Hello, Chelsea. Thank you for the follow. Okay, so Lynn is increasing. So think of the number line. If you're not sure, you can always use it as an option, guys. So if I think of a number line, so say that's 5, 4, 3, 2, 1, 0. So if this is 0, this is -5. So that's -1, -2, -3, -4. So for me to go from -5 to 2, I'm going in the positive direction. Remember, going to the right is the positive direction. So I'm increasing. So if I'm increasing by 1, 2, 3. So this is giving me +3. Okay. So from going from -2 to 1, again, I'm going up 3. We're okay? I don't know why, but younger me will never got taught about the number line. And when I look at it now, I'm like, huh. Right? Because that's basically if I drew my y-axes. Your x and y-axes are basically two number lines crossed together. And they're just meeting at 0. That's all it is, right? So from 1 to 4, I'm increasing 3. Now the reason why I'm doing it throughout the length of my y's is because sometimes there'll be a graph that'll give you like a hiccup. All right, so you want to be cautious of the hiccup. But that's your y values. The pattern is going up 3. So my slope, my y's, has a difference of a +3. Now, what's the pattern of my x's? Put that in the chat. What's the pattern of my x's? Not like my ex-lovers, but the pattern of the x's. What's my pattern? I need to get away from Tauruses. That's what my pattern is, all right? We need to break that. That's what my pattern is. There you go. A little piece of Audrey, just so you want that. Okay, so it's increasing by 2. Do we agree with Lynn and Gail? Yes, increasing by 2. Lisa, increasing by 2. Yes, okay. So we are increasing by 2. So if the pattern is going up by 2, that is my denominator of my slope. So my slope is going to be a positive slope, and it goes up 3 and then to the right 2. All right, so we're not too certain with it. Let me go ahead and draw my graph real quick. So little hiccups because my fingers are in the way. All right, so that's 1, 2, 3, 4. Here's number 5. I like to draw my 5s a little bit bigger, so it's easy to find. 1, 2, 3, 4, 5. Okay. And this helps like students, especially when they have to draw graphs. That you can draw the graph so much quicker because now you got a graph paper. You don't have to like go thumbing through trying to find graph paper. You can just go right through it. So either you can do some math problems, some extra math problems on here, or you could just go ahead and shoot a straight graph. So now I'm going to graph -2, -5. So I'm starting here at the origin, okay, going to the left 2, then down 5, plotting my point. Then I want to graph 0, -2. So I start at the origin. I don't have a left or a right because it's 0, so I just drop down -2. Then I have 2, 1. Starting at the origin, go to the right 2, up 1. And then I have 4, 4. Starting at the origin, go to the right 4, and then up 4. Look what your green, oh my green, jeez, I can't do my colors. Look what my red dots are doing. I'm building myself a straight line. Okay, so I'm building myself a straight line. Let's see if I can draw a straight line through it. There we go. Not too bad. Okay. So even if they gave me these ordered pairs and they asked me to find my slope, you can still find the slope just by graphing it. So if I graph all my points, all I need is 2 points, just 2 points to find my slope. So let's say I want to use this point here at 2, 1, and I want to go to this point here at 4, 4. So how do I move from this point to this point? Remember, rise over run. So if I start here, I can go up 1, 2, 3. So since I went up 3, that's a positive 3. And then go over 1, 2. And I went 2 to the right. So my slope is going to be my rise, which is 3, and my run, which is 2. Okay. How do I save this for later? I'm trying to figure that out. I know I have a recording. I have to see how I can download it, but I know my lives go so long. It's like trying to download like a whole thing is ridiculous. But what I'm going to do is I'm going to try to do clips of these, and I put them on my YouTube channel, but I also put them here on TikTok. So if you follow me, you should be able to see some of the clips once I release them. Okay. So as long as God's putting breath in my lungs and keeping me with the ability, I'm more than willing to break down and share concepts. Okay. This is the type of explanation that I've been looking for. Oh, I'm following you. All right. What is your YouTube name? Under Audrey Codner or ACG Math Tutoring? So keep forgetting I can write in the chats. Testing out my typing skills. Yep. Okay. Can I snapshot? Of course. Anything that I put on here, let me see if I can shrink it up so you can get that. Yep. So anything that I put, hold on. Can you see the whole screen, or is the comments in the way? Because there's like a whole bunch of stuff that's around here. It's like, yes, this. So I don't understand. No problem. I know every question, but I just get confused easily. Okay. Yes. All right. Good. All right. So when we're looking at slope, so we have it algebraically, which is what we did up here. We have it graphically, which we just did right here, which I'll repeat. So if I want to start, let me zoom in quite a bit into that. So if I have 2 points, actually I can do it with these 2 points down here. So if I have this point down here, because that's a point that's on the line, and this point right here, because that's a point that's on the line, I can find the slope by doing movement. Remember, slope is basically your rise over your run. Okay? Rise, you're either going up or down because that's your Y values. And because you can't see that one. And your run is your left to right If it's positive, you're going to the right. If it's negative, you're going to the left. For your rise, if it's positive, you're going up. If it's negative, you're going down. So we're going to try to find slope with these 2 points. So Firestorm, are you still with me? Okay. All right, true. But then, yeah, I'll try it. Thank you. But then I can't see something. Okay, we'll figure it out. We'll figure it out, but thank you. Do we measure this in degrees? Right now, we're not finding angle measurements. We're just finding the steepness, okay? We're not finding angle measurements. All right, so now I want to start from this point, and I want to go up to this point. So if I need, it's almost like all these little blocks are like city blocks. You can't go running through someone's house just to get to your friend's house. Seriously, especially in my neighborhood, yeah, you ain't gonna last long. All right, so you need to go from block to block. All right, so you're always trying to make like an L shape. So if I'm starting here, I'm gonna go up 1, 2, 3 blocks. So I'm going up 3 blocks. So that's a positive 3. Now I'm going to make a right turn and go over 1, 2 blocks to get to my friend's house. So since I went to the right 2 blocks, that's a positive 2. So my rise was 3. And my run is 2. Okay, so you just found the slope of this line. It doesn't matter if you use these last 2 points, if you use these 2 points, even if you use these 2 points. You have to reduce it, but the reduction is still going to give you 3 of 2. Okay, run positive right. Yes, when you go to the right, that's positive. You always start with the rise, then the run. It can't be run, then rise. Yeah, it could be run, then rise. You can do that. I just like to just keep it with the same pattern with the equation. That's me. But you can do run, then rise. Because if I wanted to, I could, what colors can I use? I could, say for these 2 points, I can go to the left 2, so that would be negative 2, and then go down 3. So since I went down 3, that would be negative 3 over negative 2. And what's a negative divided by a negative? It'll still be a positive 3 over 2. So you get the same exact slope. You just might have to do a little more simplification than normal. Both are correct then. Yep, cool, yep. That'll work. All right, how are we feeling? Oh, thank you for the likes, guys. My goodness. Love this. I just looked up. I was like, oh, there it is. Okay, how are we feeling? Thumbs up. Feeling pretty good. Celebratory. Okay. Hit us with a hard one. Okay. I mean, I don't know how hard we can get with slope, except for, I told you there was 4 ways, right? So we have algebraic, we have graphical, we have numerical. I didn't tell you the 4th one. You're like, oh, she's evil. Let me see if I can find it. Oh, goodness. I didn't trim this properly. My fault. You have standard form, negative AB. I love that one. Okay. I feel I learned something new today. I hope it sticks to my brain. It will. With practice, it will. Meaning the quadratic equation. Yep. Now, factoring, that is my evenings. Factoring is my evenings. Something that we all love. We all love these. What is she doing? I don't see what she's doing. Do. Okay, so let me unzoom a lot. Okay. Why am I like all kinds of crazy? Like practically off the table. All right, so word problems. Okay, we have to do this verbally. You're like, no! I can hear it. It's really faint, but I was like, ah. Like all the little souls just being sucked out of your life. It's okay. I'm going to help you through it. All right, let me see if I can get everything in here. All right, so here we go. All right, the ladder of a straight slide in a playground is 8 feet high. The distance along the ground from the ladder to the foot of the slide is 12 feet. Approximate the slope of the line. Ooh, what are we doing? Okay, so this will be our last thing because I am definitely need to make some phone calls. Okay, so we have a ladder of a straight slide. Remember those deaf slides that we used to deal with, right? If you haven't like dealt with a deaf slide, you haven't lived. You just haven't lived. All right, so it's one of those straight slides up and down. And they're saying that the ladder of it, okay, is 8 feet. All right. The distance along the ground, so that'll be down here, kind of overshot it a little bit. So the distance along the ground from the ladder to the foot of the slide is 12 feet. So we're saying that from here to here, it's about 12 feet. Ugh. So now they want us to figure out what is the slope of this slide. Okay, we can handle this one of two ways, but let's handle it using slope. Let's use our brains a little bit. All right, so if we're looking at, they're saying that this is 8 feet high. So if they're saying that this is 8 feet high, we're just going to use, I'm going to say that this, the coordinates of this point is going to be 0, 8. Because right here, this is my origin. 0, 0. Okay, you wanted a little harder one. I think we got this. Had to come back, the Wi-Fi is not working. Okay. All right. So now, we can use, yeah, I think I know what you're talking about. Pythagorean's theorem, we could. That is a possibility. But we could also use slope. So if this is my origin, and they're saying from here to here is 8 feet, that means this point is at 0, 8. If we're saying from here to here is 12 feet, that means the ordered pair of this has to be 12, 0. Remember, this is your x-axis, that's the 12. This is your y-axis, that's the 8. So now you have two ordered pairs. So if you want, you can say one of them is 0, 8. That'll be your x1. This will be your y1. Then we have our 12, 0. This is my second point, so this will be my x2 and my y2. So depending on which one you want to use, you could do y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Either way, tell me my slope. So do you think that's your answer, Lynn? No second guessing. Be confident with your answer. So whatever you think you have, put in the chat. Okay, so I'm seeing some 4/3. Oh, okay, and then we have 2/3, 2/3. Okay, we have 2/3. What do you think? Hello, N. Welcome in. Give me a couple more people. Even question marks. You're just like, I'm trying and I'm not sure. Okay, so now we have a negative 2/3. Okay, why they're not negative? Did I do something wrong to get negative 2/3? I have 2/3. I have a couple question marks. Thank you for your honesty. Okay. All right, so let's see. If we used, let's go with y1 minus y2 over x1 minus x2. So my y1, that's 8. My y2, that's 0. So it should be 8 minus 0. My x1 is 0. My x2 is 12. Okay, I didn't have to put any parentheses because I didn't have any negative numbers to plug in. All right, so now, and it all depends on numbers to plug in. All right, so now, and it all depends on which one you. Sorry, someone was trying to call me. Okay. All right. Either way, okay, either way, you're going to get the same answer, right? So now, 8 minus 0 gives me 8. 0 minus 12 gives me a negative 12. Okay? 8/12 can be reduced. 8 and 12, since they're both even, that could be reduced by 2, but that's not my greatest common factor. My greatest common factor is going to be 4. So if I reduce that 8 by 4, I'm going to get a 2 over negative 12 divided by 4 gives me a negative 3. So yes, you are going to have a negative slope, and it is going to be a negative 2/3. Okay? Right. Yeah, someone tried to call me, Lisa. Crazy. I'm like, why? You know I'm busy at this time, right? Plus, if we just take a moment, look at the graph. They want us to find this part right here. Oops. If you notice, from left to right, what is that slope doing? It's decreasing. So as my x's are increasing, my y values are decreasing. Okay, so I have to have a negative slope. So when I did see some 2/3 in there, and I didn't say anything, I didn't want to say anything from the beginning. I really wanted to get a lot more people kind of involved. But at the same time, you got to definitely take a look at what direction your line is going through. If it's going downwards, it's going to be negative. Okay, so we do have a negative 2/3. Couldn't count and check for it. That's all right. We'll see. It's always good for you to double check. Okay, the internet is messing up. I'm sorry, the internet. What's the answer? Okay, so the answer was a negative 2/3, Lisa. Okay. All right. How are we feeling? Okay. Lovely Bones, you got it? Okay, good. All of a sudden I can't move things. Okay. So even those people that did it y2 minus y1, you're going to get the same answer. Okay. So if you did it y2 minus y1, that means you had 0 minus 8 over 12 minus 0. So you got yourself a negative 8 over a positive 12, which could be reduced to a negative 2/3. Okay, you're going to get the same exact answer. You're still going to get a negative slope. Okay, I think I feel good about now. Good. Okay, I got it. Great. Yep, love it. Okay, that's without the subtraction. Yes. All right. I really need this for my pilot training. I understand it, but I'm still getting the wrong answers. Is it how you're plugging it into the formula, Holly? I'm just curious now. Okay. All right. Yeah, just write in what you got, Holly. Bridget! It's so nice to see regulars, too. It's so nice to see new people at the same time. It's just nice to see people, period. And then hopefully I am being somewhat helpful. Okay. All right. Okay. Got a nice little raven out my door right now, or my window. Okay, hopefully this time I'll do a GED exam and I'll pass. Okay, that'll be awesome. Yes. Now, here's my thing as we're going through this with the GED. Remember, everything is not even keeled. Like anything dealing with linear, like linear equations, your slope, those are considered 4-point questions. So if you hit hard with those and you get the whole adding fractions, decimals, and percents, like all the basic questions, and you get more of these type of questions done, you're going to pass. Okay, I failed 3 times. It doesn't matter how many times you fail, it's how many you're going to pass it. Hell, I took the praxis just to be a math teacher. I took it 11 times. 11. Right? I mean, I just did the normal thing. I took the test, I came home, signed up for the next one. It was just like, that's what I had to do. And I just had to work. And the fact that you're doing it and you're not letting it discourage you, I'm very proud of you. I just want to let you know that. And that's from the heart. Okay, good. Yeah, you've done great now. Look at me. I don't even know how I became a math teacher. I mean, I was terrible at this. All right, so I'm getting ready for my SATs. Good. Now the SATs go all the way to Algebra 2. So have you completed, Lynn, have you completed Algebra 2? Not a problem. Yes, keep practicing, definitely. Keep practicing, keep asking questions, because I know we're going to be doing a lot more of slope stuff. All right. Okay, so for today, I kind of want to stop right here because the next part, we're going to be looking at the equation of the line. And I'm one of those. So Algebra 2 will comprise of factoring. Let me think. So all of this linear stuff, factoring, quadratics, your absolute values, solving system of equations, matrices, systems of inequalities. Let me see. No, not that far. Not signed. That's trig. What was the last thing? Oh, and cubic functions and doing logarithmic and exponential, as well as rational function and radical functions. Okay. Okay. I'm one champion, Mom. I have to go over matrices. Yeah, I know I will be. Are you going live tonight? Yes, I will be going live tonight at 8:30 Eastern Standard Time. And we're actually going to be working more on factoring and factoring by grouping. All right, good afternoon. This is only class you have for the afternoons. Yes, but I will be back on at 8:30 this evening to do mostly factoring this week. So I did factoring of GCFs last night, and then we're gonna do a quick review and then go into grouping, and then I'm gonna show them how to factor trinomials. So that's gonna be a huge part. Our class is online via live only. Yes. I mean, it's yes. Yeah, because I only go live, but I do have online tutoring, and I finished up my courses. I do have courses to help people with like GED, ACCUPLACER, ASVAB, and also general like math skills. And it's like 107 videos. It goes all the way up and includes some parts of statistics and probability. And it does go with like the system of equations. So I kind of went up a little bit more with it. The only thing I hate is word problems. Yes, and volume. That's my biggest weakness. Volume is really understanding the formulas. If you understand the formulas, you'll be able to figure it out. Especially if you can understand what a cylinder and what a rectangular prism is, just those two. You know, a pyramid is basically 1/3 of a rectangular prism, and a cone is 1/3 of a cylinder. So if you can memorize cylinder and rectangular prism, and then just take your answers, divide by 3 to get the other two, and you can get those formulas done. All right. I'll definitely join. I really want to get this maths. Said it 4 times. I am tired. I know. Okay, the last time I said it was just 1 point away from the passing mark. Oh, I know. That's the killer. That's the worst. I mean, it's like you work so hard, and then you're like, okay, let me see my score, and you're like, 1 point, 1 point. Oh, Lisa. Oh, well, here it is, Lisa. Continue to study the way you are, but really try to get these type of problems. If you can get a few of those linear problems, you're going to pass it. Will you talk about cylinder or volume in the future? I don't know when, how far in the future, but I know I will be talking about it. I will be talking about it. Yes, please. I was like, thank you, miss. Yes, you can definitely do it. You can definitely do it. And I think that's the problem. A lot of people don't know, especially for the GED, your test is not like 1 point per problem. There's some 4-point questions and there's some 1, 2, and 3-point questions. But anything that's dealing with graphs, those are going to be your 4-point questions. Anything dealing with graphs and slopes and the equation line that we're going to talk about actually tomorrow, they are like your big ticket items. Okay, I need all the help before March 8th. Okay. What time will you be on tonight? 8:30 p.m. Eastern Standard Time. What are your websites for tutoring and courses? It's in my bio. If you click on my face for the profile, it's right in the bio. It's ACGMathTutoring and .com. So you'll be able to see, like, I have the links for the courses, and if you just want to do like a monthly, which is a little bit cheaper, you can do that as well. And where live in the same time. Yeah, I'm in Baltimore, Maryland, so I'm on East Coast time. What my niece struggles with too. I just had to help her with it. With volume. I'm trying to see what you guys were talking about that. Oh, with cylinder and volume. Yep, because cylinder is basically the area of the base times your height. So let me shoot a quick piece of paper, and then I have to go definitely in 3 minutes. But if I have a cylinder, not too bad. But with a cylinder, your base is a circle. So the area of the circle is pi r squared. Okay? So it's the area of your base, and then you're going to multiply it by whatever the height is. So if they give you, let's say, a diameter of 18 inches, okay, it's a very big cylinder. And let's say that the heights, let me unzoom a little bit and angle so we won't have to be all kinds of crazy. Okay. So let's say that the height is, let's say it's 20. Why not? So we got 20 inches. I don't know, it's a nice big can. Okay. So if they give you the diameter, notice our formula doesn't deal with diameter. It deals with radius. Radius is half. Okay? So your radius is always going to be half your diameter. Okay? So that means if I want to do the volume means fill. Do not want to play games. Okay, so the volume means fill. So my radius, so we got our pi, our radius, which is half of 18, which is 9, squared. A lot of people forget that part. Okay, area of a circle always deals with squares, times your height, which is 20. So now you're not squaring the whole equation. That's always an option of one of the answers as well. You're just squaring the 9. So 9 squared. 9 squared is the same as 9 times 9. Not 9 times 2. No. Don't do that. 9 times 9. So that means I have my pi. I have 81. And I have 20. Okay? Right now, don't assume that pi is just going to be 3.14. Stop it. Unless they say it. And also look at your answer choices when you take the test. If you still see pi involved, that means you're only going to multiply these two things and leave the pi. It's almost like the pi is like a trifling ass friend. You know that friend that you go out with and they never have any money, but they always want to go out? Yeah, that person. All right, I got like 4 of them. I don't know why we're still friends, but we'll digress about that. So now we have 81 times 20. So this will give me 1620 pi. So I bring down my 0. 2 times 1 gives me 2. 2 times 8 gives me 16. And I just bring down the pi. Now, if they just leave it like this, great. Look for 1,620 pi inches cubic inches. That's huge. So when you basically look, okay, when you look at your answer choices, go straight to the units. If I see a square right away, I know they're not talking about volume. Volume always looks at that third dimension, always deal with the cubic. So if you see anything that says n squared, cross it out. You might be able to reach it down to like maybe 2 answers. And then you will just do your squaring, which gives you 81 multiplied by the 20, which gives you this. And this is your true answer. But they might ask you to approximate, and that's when you use the calculator for the pi. Okay. Leave the pi. Yes, don't convert anything to 3.14 unless they say convert, use 3.14 for pi. If they don't say anything about 3.14, leave it as pi. Okay? But if they say, okay, convert that to 3.14, that means you got your 1,620 and you're going to multiply that by 3.14 and you're going to get a lovely answer, which I'm not going to lie to you. I'm going to use a calculator because my brain is not a human. I am human. All right. So this gives me 5,086 and 8/10 cubic inches. And I'm going to use my whole approximate. Every time you see like these little waves, that means approximate because I round it, because this is not what pi is. Pi is a heck of a lot longer than that. So we only took a small phrase of pi. The shade. But it's true, and they know they're trifling, and it's hilarious. And I don't know why we're friends, but here we are. So if they gave pi, hypothetically speaking, okay, a value says 3.14, you just multiply that into the formula. Yes, I think I got it now. Thank you so much. Not a problem. Yes, if they say convert, then you convert. There you go, Lucas. That's why you're #1 slot. Okay, thanks. Got it. Not a problem. All right. Yeah, so that's what volume is. Now, here's devil's advocate. Again, me always on the shade. I'm waiting for that phone, that little knock at the door. Oh my goodness, he's hilarious. He's like slipped a note. Are you done? Almost. I'm finishing up. I swear, I'm finishing up. I know it's so hard to just let go. But if anything, if they said this is supposed to be like a cone, like I said, the formula for a cylinder is volume equals your area of your base, which is pi r squared, times your height. That's for a cylinder. For a cone, you just do this. Divide by 3. That's the volume for a cone. That's it. What is the pi? Sorry, I never studied this kind of math. Oh, pi is usually used for circles. Pi is usually used for circles. Thank you for teaching. Use. Not a problem. Us, yes. Not a problem. Okay. So if you ever get stuck and they say, oh, I want to have the cone, if they want you to do a comparison of which one has the most volume, well, if they compare the cylinder to a cone, because remember, a cone looks like this, somewhat like that, you're taking a third of your cylinder. Let's pretend that this is straight. Let's just pretend that was really straight. Okay? So a cone is basically 1/3 of a cylinder. So if they say which one has the most volume, it's going to be the cylinder. Because a cone, you have to take 1/3 of how much a cylinder holds. All right? All right. Typo. Not a problem. All right, guys. I have to get going. I would love to stay and do more. But tomorrow, we're going to be working on equation line at 1 o'clock. Tonight at 8:30, we're going to be working on factoring by grouping. Okay? And if I do have time, I will probably teach a little thing called the AC method. But yeah, I'm going to try to get everything together. So we enjoy. Oh, not a problem. Bye. Thanks again. Not a problem. Have a lovely day, and hopefully I might see you guys this evening. All right. And again, if you want to buy the book, it's on Amazon, or you could just visit my website. If you ever have questions, you can contact me through there, or you can just direct message me here on TikTok if you ever have any kind of questions whatsoever. All right. Well, have a lovely time. And if not, if I don't see you tonight, I'll see you guys tomorrow. All right. Take care. Bye now.